Today we will solve the Cbse question bank for probability. Our main focus will be on the Bayes theorem. We will see how to organize the given data in the form of a table. But then we will start with some preliminary stuff. We will see how to translate English words into mathematical terms. Suppose you have two events A and B. Then what do you mean by the probability of A and B happening? It means the probability of A intersection B. Why is that? If you draw the Venn diagram, you will see that the elements which belong to both A and B are the ones which lie in the intersection of A and B. When I say the probability of A or B happening, then it means the probability of A union B. Why is that? When we say A or B, it can lie anywhere in A union B. The third thing we learn is the difference between mutually exclusive events and independent events. What do we mean by mutually exclusive events? Two events A and B are said to be mutually exclusive when they have nothing in common, or in other words, their intersection will be a null set. Suppose you roll a die and then let A be the event that the number that turns up is even. Let B be the event that the number that turns up is odd. Now, can you think of any number which is both even and odd from 1 to 6? There is nothing of that sort. So what do you have? You have probability of A intersection B is 0. Why is that? A intersection B will be a null set, so its intersection will be 0. But then what will be the probability of A union B? You remember the formula that you learnt in 11th standard? It will be probability of A plus probability of B minus probability of A intersection B. But then if they are mutually exclusive, A intersection B is 0. That means your equation reduces to this. So that is what we mean by mutually exclusive events. So mutually exclusive events, when you have two mutually exclusive events, their intersection, probability of their intersection will be 0 and probability of its union will be the sum of their individual probabilities. Now, next, what do you mean by independent events? Two events are said to be independent when the result of one is not influenced by other. Again, suppose you are rolling a dice and you have two cases. Two events A and B. Suppose A be the event that the number that turns up is a multiple of 3. And let B be the event that it is an even number. The number that turns up is an even number. Now tell me, what is the probability of A? Any probability is favorable outcomes by total number of outcomes. What is the total number of outcomes? The dice has 6 numbers. So 6 is the total number of outcomes. What are the favorable outcomes? There is only 2. What are the two multiples? 3 and 6. So probability of A is 1 by 3. And what will be the probability of B? Again, favorable outcomes by total number of outcomes. Total number of outcome is 6. What are the favorable outcomes? How many even numbers? There are 3 even numbers, right? 2, 4 and 6. So this is 1 by 2. Now consider A intersection B. Can you think of the numbers from 1 to 6 which will satisfy both the conditions, which will be a multiple of 3 and will be an even number? There is only one such number. What is that? It is 6. So the favorable outcome is 1, the total outcome is 6, so it is 1 by 6. Now, did you notice one thing here? the probability of A intersection B is equal to the product of probability of A and probability of B. Their intersection will be equal to the product of their individual probabilities. Now you see the difference between these two. It is very easy to get confused between mutually exclusive events and independent events. But you see the difference here. In one case, the intersection is 0, and in the other case, the intersection is the product of their individual probabilities. And when do you think an event will be both mutually exclusive and independent? When will that happen? That will happen when PA into PB is equal to 0. That means, and when will that happen? When is the product of two numbers 0? When one or both are 0. Or in other words, when one or both are null sets. Now we will start doing our questions. Here comes the first question. What is the first question? There is a shooting range. There are 3 people practicing there, and the probability of A hitting the target is 4 by 5. Then what will be the probability of A missing the target? It will be 1 by 5. Similarly, the probability of B hitting the target will be 3 by 4. Then what will be the probability that B misses? 1 by 4. Similarly, C, the probability of hitting the target is 2 by 3. And the probability of missing it is 1 by 3. So now you have 3 events, A, B and C. A is the event that this person A hits the target. So what do you have? Probability of A is 4 by 5, and then probability of A complement. What is A complement? If A is the event that this guy hits the target, A complement will be him missing the target. Similarly, B. If B hits the target, we have 3 by 4. Then B complement is B missing the target, and same with C. The probability of C is that this guy hits the target, and C complement is that he misses the target. So, the first question is, what is the probability that A and B and C hit the target? What do we mean by and? And means intersection. And then these are independent events. So the result of one person hitting the target is not affected by the other guy. So then what do you have? Probability of A into probability of B into probability of C, which is this into this into this. That would be, then you have cut. It is 2 by 5. And let me see what option it is. It is C. The answer is option C. The second question is that what is the probability that B will hit and C will hit and A will not hit? That means A complement happens. So the probability of B happening, which is 3 by 4, the probability of C happening, which is 2 by 3, and the probability that A will not hit, which is 1 by 5. So your answer will be it will be 1 by 10, and the correct option I see here, it is A. A is the correct option. We come to the third question. What is the third question? It is the probability of 2 of them hitting the target. We don't know which 2. So then we can have 3 probable conditions. What are they? A hits and B hits, but C does not hit, which means C complement, or. Remember what or is? It is union. A does not hit, but B and C hit, or A hits and C hits, but B does not hit. So you have 3 such conditions. So what is the probability here? Here you see and, which means intersection. but these are independent events, so that means P of A into P of B into P of C complement. But then you see the OR here, it means plus. Why? Because it is union and it is mutually exclusive events. So OR means plus, which means P of A complement into P of B into P of C. Again you have an OR, you have a mutually exclusive event, which means the intersection does not matter. So again you have a plus into. Yeah. So now let us start writing the values. 4 by 5, 3 by 4 and 1 by 3. That would be 1 by 5. And the second would be A complement 1 by 5 into 3 by 4, 2 by 3, which would be 1 by 10. And the third one is A and C 4 by 5 into 2 by 3 into B complement would be 1 by 4, that is 2 by 15. That would be LCM 30, and you would have 6 plus 3 plus 4, that is 13 by 30. And then we come to the fourth question, which is the probability that nobody hits. A does not hit, so A complement, B complement and C complement. All of them are independent. So what do you have? Probability of A complement into B complement into C complement, and what would that be? That would be 1 by 5 into 1 by 4 into 1 by 6. No. That would be 1 by 60, right? Yeah. It is a bit of a tricky question. What does it say? What is the probability that at least one of them hits the target? Now what does that mean? If I tell you, give me at least 1 rupee. What does that mean? Give me 1, 2, 3. That means give me 1 rupee means 1 is my lower limit. You can give me as many rupees as you want. So what do we mean when we say at least 1 hits? It means there are 3 probabilities, like at least A hits, or at least B hits, or at least C hits. But then if at least A hits, what about B and C? There can be so many combinations, right? Suppose A hits and B and C also hit, or B and C do not hit, or one of them hits. B hits, C does not hit, or B does not hit and C hits. Similarly, for each one of them, you see how complicated this all this calculation is going to be. So what do? We find the complement of this event. Suppose this event is, say, D. D is the event that at least one of them hits. Find its complement. Now how is that going to help? The probability of any event and its complement will be equal to 1. So what will be the probability of D? It will be 1 minus the probability of its complement. So whenever you see such a calculations, you have too much to calculate, then usually its complement will be easier to calculate. And then what is the complement? Then I say at least one person hits. Or if I say at least give me 1 rupee, and when you say no, then what does that mean? You are going to give me 0 rupees. That is exactly what it means. If D means at least 1 hits, then D complement means no one hits. That means A complement and B complement and C complement happens. And what does that mean? We have already found its probability, right? Its probability, just the previous question, it was 1 by 60. So your answer is 59 by 60. So please remember, whenever the calculation gets very muddled, go to the complement. Now, our next question is about the reliability of a certain PCR test. We have a certain population, a town maybe. There are some people who have COVID and there are people who are free of COVID. The probability of people who have COVID is 0.1%. Then what is the probability that people do not have COVID? It will be 99.9%. Why is that? You see, these are two disjoint events which make up the whole sample space. So the probability of C plus probability of F is equal to the probability of the whole sample space, which is 1. So probability of F will be 1 minus 0.1%, which is 99.9%. So please remember this answer, because this is actually our third section. This question has 5 subsections, and this is actually the third question. What is the probability of F? So this probability is 0.1%. This probability is 99.9%. Now, in this population, everybody underwent a certain PCR test. And in this group, the people who had COVID, 90% of them turned out that they were COVID positive. That is fine. But you see this 10%? This is a very dangerous 10%. These are people who actually had COVID, but the PCR test could not detect it. So the PCR test showed them to be negative. So these people are out there in supermarkets and colleges infecting people. So the PCR test failed 10% times. But what about this? Here, 99% times it showed as negative. Correctly showed. They did not have COVID. No, they are free of COVID. So 99% it showed that they were negative. But then this 1%, that came up to be wrong. They were free of COVID, but then it showed that they had COVID. So that 1%, it failed. Now, randomly, one person was selected from this population, and it turned out that that person was positive. Now comes the question, did he fall in this group and he was rightly diagnosed as having COVID, or did he not have COVID and he was wrongly diagnosed here? So that is our question. So we go step by step. What is the probability of A given C? So with conditional probabilities, always assume this has already happened. The person already has COVID. So assume that this has happened. Then what are the probabilities of this thing happening? So what does that mean? We are considering only C. We are not bothered about F, because it is a conditional probability. It gives C as the main event that happens. So this person has COVID. So that means this person falls in this group. He was correctly diagnosed. And what is its probability? 90%, which means 0.9. Now, the second. What is the probability of A given F? That means you know for sure he falls in this group. He does not have COVID. But then the PCR test has messed it up. It has shown that he is positive. So what will be that probability? Go to this group, 1%. He falls in this group. So it is 1% means 0.01. And the third thing, as I said, if you remember, what is the probability of F? The probability will be 1 minus probability of C, which is 1 minus 0.1%, which would be 99.9%, which will be 999, a point here. Now the fourth question, what is the probability of C given A? Now we are in a pickle. Why is that? A given C was easy. You just had to look at the chart. That is why we assemble the whole facts in the form of a table. You can just look at it, no? Go to C, go to A, you have the answer. But then here they are asking that it is known that he is positive. So then what are the chances that he lies in C? So what do? Favorable outcomes. We know that, no? The favorable outcomes comes in the numerator. This is where the Bayes theorem helps us. We have to apply the Bayes theorem. What does Bayes theorem say? The probability of C and the probability of A lying in C. The same term comes here with one additional term. Probability of C, the probability of A lying in C, plus probability of F plus probability of A, into probability of A lying in F. That would be here, this into this. This is probability of C and this is the probability of A lying in C. 0.9. The same term comes down, but then with one extra term. We have to add one extra term. The probability of F into the probability of A lying in F. And that would be 0.009 by 0.009 plus 0.00999, and the answer will be, this will be your answer, 0.083. This will be your answer. Now we come to the fifth question, which is, I'm not rubbing the last one because we need it. The fifth question and the last question is, what is the probability of A? What is the probability of A? It is just the numerator. What is it? The probability of C into the probability of A lying in C. The probability of F into the probability of A lying in F. C, A given C plus F, and probability of A given F. This would be 0.01089. So this is our answer. So now we come to the next question. This is also an application of the Bayes theorem, and so we will quickly go past the question, okay? A student is writing an exam, and there are two things that can happen. Either he knows the answer for sure, that is the event E1, or he does not know and he is just guessing. So the probability that he knows is 3 by 5. So what will be the probability that he does not know? It will be 2 by 5. Why is that? Because these are two disjoint events that make up the whole sample space. So added, they should give the answer 1. So in case such probabilities are not given, it means that they are equal. So if you have 2 events, take 1 by 2, 1 by 2. If you have 3 events, take 1 by 3, 1 by 3, 1 by 3. So they added should give you the answer 1. So always remember that. So E1 is the event that he knows the answer for sure. E2 is the event that he guesses it. But then, whenever he guesses it, does he get the answer right every time? The answer is no. The answer is correct only 1 by 3 times. 1 by 3 times he gets the correct answer. That means 2 by 3 times he gets the wrong answer. What about E1? E1 is him knowing the answer, right? He knows the correct answer for sure. 100% it is the correct answer. So what is the probability of him knowing the correct answer? The full probability, 1. And what is the probability that it is wrong? It is 0. So randomly we are considering the event that one of his questions has turned out to be correct. So this is a random question. We don't know if he knew the answer for sure or he was just guessing and it turned out to be correct. So we don't know that. That is what we have to find out. Did he really know the answer or did he just get lucky? That is what we will find out. What is the first question? The first question is what is the probability of E1? We can see that from our chart. It is 3 by 5. And the second is what is the probability of E given E1? Again, it's easy from the chart. Go to E1. What are the options that, what is the probability that the answer is right? 1. Third, sigma probability of E given Ek into the probability of Ek where K varies from 1 to 2. What is that? The probability of E1 multiplied by the probability of E lying in E1 plus the probability of E2 into the probability of E lying in E2. Or in other words, what is this? This is actually the probability of E. This is actually indirectly they are asking for the probability of E. E by 5 into 1 plus 2 by 5 into 1 by 3 which is 2 by 15 which would be LCM 15 which would be 11 by 15. Now we come to the fourth question. The fourth question is sigma probability of Ek where this K is 1 and 2. That means probability of E1 plus probability of E2. That will always be 1. 3 by 5 plus 2 by 5 is 1. This brings us to our last question. What is the last question? Come to the fifth question, which is what is the probability of E1 given E? Now, the probability of E given E1 is very easy. Why? Because we are first considering the case E1. We only have to worry about this. We don't have to worry about this. So, therefore, go to E1. Find the probability of it being right. But then here we are first considering that he got the correct answer. So what is the answer? The probability of E1 into the probability of E falling in E1. The same term gets repeated in the denominator but it comes with one more term. What is that one more term? It is the probability of E2 and E falling in E2. That would be 3 by 5 into 1. So that is 3 by 5 here. The same term comes down but with one extra term. What is this? 2 by 5 into this. That would be 2 by 15. It would be 3 by 5 by 11 by 15. And that would be 9 by 11. So this is our answer. With this we come to the end of this video. Take care till we meet again. Assalamu alaikum.